Okay, minasan, konnichiwa, Zamurai Engineer desu. So in this live stream, let's talk about block shear under tensile limit state or tensile strength limit state. So we have to wait for sound check confirmation. So we are now dealing with the block shear. So let us just take a very short discussion of all of this, and then next meeting we will just talk about the theory. So what could we expect from the code, from the manual when we are talking of block shear? So let's take a look. So for block shear, we have the following. So from the code, we have equation J for -5. So meaning chapter J. Chapter J, section 4, -5. So block shear rupture strength, and we have the following formula. Okay. So it is a block, meaning it consists of so many things here. So 1, 2, okay? So these things must be equal or less than these things. So as you can see, you have the value for U, which is here UBS. It is equal to 1 or 0.5, 1 for most tension members, okay? The value of UBS, okay? What's next? What about A and T? What do you mean by A and T? This is net area subject to tension. So A and T. What about the A and B? A and B is the net area subject to shear. So it is what? Combination of shear and tension. Okay? What about the area GB? This is the gross area subject to shear. Take note, we are using V as in victory when we are referring to shear. So that's why area GB, gross area for shear. Okay? So NT, that is area for net area for tension. Okay? And so on. When we are using LRFD, phi is equal to 0.75 for block shear, while omega is equal to 2 for ASD. Okay. Then, lastly, this last slide for the block shear, we have what? We have block shear rupture strength, again, with emphasis on the following. Okay. So again, UBS is equal to 1 or 0.5. Okay. But take note, we have the factor 0.6. Okay? We have the factor 0.6. So we are actually having a two equation which we are going to compare. So the equation on the right must be greater than or equal to the equation on the left. Here, this must be equal or greater to this. But you will notice that this second term is equal to the second term here. Therefore, we will just compare these two. And this is what? Tensile point. This is ultimate point. They are both multiplied by 0.6. One is gross, of course, tensile, yield rather. Excuse me. I have to say yield rather than tensile. This is yield. This is ultimate tensile. Yield multiplied by gross. Ultimate multiplied by net. And that is usually our formula here. Okay. So that is for shear. So the first term are for shear. The second terms are for tension. So this is a combination of the two. Okay. Shear and tension. Okay. So that's all for the expected provision from the code. Okay. Let's go to the next discussion. Code provision for bearing and tear out at bolt holes. Okay. What can we say about that? What provision is brought in by the code? So bearing and tear out at bolt holes. Again, phi is equal to 0.75, therefore omega is equal to 0.2, rather 2. So bearing strength at each bolt, Rn meaning nominal resistance is equal to 2.4 dtFu. Okay. What do you mean by dt? D, nominal bolt diameter. T, thickness of connected material. So same as we are always using before. But you will notice this is equation J3-6a. Okay. For tear out strength at each bolt, that is Rn is equal to 1.2 LC TFU. So both they are multiplied by FU and dt is the area and multiplied by 2.4. If we are going to tear out, that is 1.2 and that is corresponding to equation J3-6c. Okay. What do you mean now by LC? This is clear distance. The direction, the distance between the edge of the hole and the edge of the adjacent edge of the hole and the edge of the adjacent hole. Okay, hole to hole. But we are not looking at the center to center distance, but edge to edge distance of hole. Okay, of the material. Again, Fu is the tensile strength. Okay. Then for the last slide in this topic, bearing and tear out, when deformation of the bolt hole is not a design consideration, okay? Deformation, there is no bolt hole deformation. Bearing strength is Rn is equal to 3 dtFu. Okay? That is now J3-6b of the code. What about tear out strength? 1.5. So you will notice tear out strength is always 1/2 the bearing strength. Okay? Tear out strength is always 1/2 because the factor is 3.0. For tear out is 1.5. On the previous slide, that is 2.4. For tear out, 1.2. So always 1/2 the value. Okay? But it is not actually entirely 1/2 because the area being considered in bearing is dt. The tear out area being considered is LC times T. Okay? So different area being considered when we are talking of bearing. Okay? So for long slotted, okay, for long slotted holes with the slot perpendicular to the direction of the force bearing strength at its bolt, Rn is equal to 2 times dt, okay? While, as you can now conclude, okay, as you can now conclude, for tear out strength, the factor is 1.0. It's 1/2 the factor, okay? But still, the formula for tear out strength is Rn is equal to 1.0 LCT times Fu. Okay? So even if that formula is not on your screen, okay, it could easily be concluded, okay, by comparing all the pair of equation, okay, pair of equation. So that is the slide for the fourth consideration. Again, to summarize, there are 4 considerations for strength limit state. That is yield, rupture, and bearing, and what is the third one? Black shear. So there are 4: yield, rupture, black shear, and bearing and tear out. Okay. So black shear, we are combining shear and tension. Bearing and tear out, we have the following formula and following factors. Okay. So for the summary of this consideration, so again, we already took note of this previously. Okay. So therefore, in our design, we will use tables 5+1 to 5+8. This is a list of available yield and rupture strength for typical section. And expect this. This is always given in board exam. The questionnaire booklet, we have the pages at the back. There are pages at the back which have the series of tables, diagrams, drawings, and so on. Okay? So you can use those things. Okay? So if you can practice more and more using table, you will have better chance on steel design in the board exam, because they are most likely use of table and application of formula and concept. Okay? And use care. These tables assumes effective net area is equal to 0.7 gross area to 0.952 gross area. So that is usually the range of values. Okay, we encountered AE is equal to 0.6, meaning U is equal to 0.6, case number 8. But that is not the usual. That is special case. The usual, this table assumes 0.7 to 0.952 multiplied by gross area. You must check this in the member and connection. So if this is met by that design. Okay. So again, table 7-4 provides bearing strength at bolt holes. Table 7.5 provides bearing strength at bolt holes based on edge distance. Okay, these tables check bearing and tear out. Note that edge distance, effective length, and bolt spacing S are measured to the center of bolt holes rather than edge of the bolt holes. Okay, so there are 2 types of hole-to-hole distance: center to center or edge to edge of the holes. Okay, and that is the last slide for the day. I will wait for 15 seconds to accept your questions, and thereby I will reply to those questions and answer them if I can. Okay, So let's do that. And while waiting for your questions, okay, so I will also take a look at the comments while waiting. Okay, so there are no questions on the comments. Okay. So last 10 seconds. We are nearing and nearer to the finals, and we don't know if we can present even 80%, 85% of the topic because of the time constraints, not only the required time in the syllabus, but the problem between the pandemic times, the restrictions, so we cannot do it as much as we can. However, please do so on your own. You can always ask questions from me. You can always ask guidance from me. Don't waste your time if we cannot do it all in our time frame, the time period, in the allotted time for our course. You can still do it on your own and just ask questions if ever you encountered problems. Okay? Do not waste your time. This is a very good opportunity to learn a professional course. Okay? Again, there is no question. This is Dr. AP. See you next meeting. And we're always trying to build a nation. Thank you.